In this video we will learn about transpose of matrix. So by definition of transpose of matrix we can say if A is equal to Aij m cross n is any matrix, then its transpose is a matrix written as A transpose equal to Bji n cross m, where Bji is equal to Aij. Now it looks like a complex definition. Okay, let's make it easier. Okay, if A is equal to Aij m cross n is any matrix. So by Aij I mean any element present in matrix A present at the ijth location, and this matrix A is of order m cross n. Now its transpose, the order of matrix is reversed. So that's why here the order of A transpose matrix is n cross m, whereas in original matrix it is m cross n. Now this Bji means any element present at jith location in A transpose. The element which was present at ijth location in original matrix, it moves to the jith location in the A transpose. So that's why it is written Bji is equal to Aij, because the element which is present at ijth location in A matrix, it would be present at jith location in A transpose. So the important points here are ijth element becomes jith element in the transpose of matrix. The second point is each row, we can also say each row of original matrix, each row of matrix A I would say, becomes corresponding column in the transpose of matrix. Or each column of matrix A becomes corresponding row in the transpose of matrix. For example, the first row which is present in matrix A becomes first column in the transpose of matrix, and the second row in matrix A becomes the second column in transpose of matrix. Similarly, each column, for example, in a column 1 becomes row 1 in transpose of matrix, and column 5 becomes row 5 in transpose of matrix. We will take example and it will be more clear to you guys. And the third property is order of matrix is reversed. For example, if matrix A is of order 2 cross 3, then its transpose order would be 3 cross 2, so its order is reversed. Now let's take an example. I have matrix A here and I want to find its transpose 2 1 3 2 4 7. The easier way to do this is to go through point 2, and it's pretty simple, but we should have understanding of point 1 also. So let's go through point 1 first, and then you can apply point 2 always to find the transpose of matrix. Okay, which according to point 1, ijth element becomes jith element in the transpose of matrix. So element which is present at 1 1 location, ij 1 1 1 1 element is here. The element which is present in first row and first column, it's 2, so it will remain at the same place. So element 2 will be remaining at the same place, and element here 1 2, element which is present in first row and second column, it will move to 2 1, and it will go to second row and first column, so it will move here. Similarly 1 3 will move to 3 1, and this element is 2 1, it will go to 1 2, and element 2 2 will, the element which is present at 2 2 location will remain at the same place, and 2 3 will go to 3 2. Now according to this, all these, we can find A transpose equal to, now this element will remain at the same position, and this 1 moves here, and this 3 moves here, and this 2 goes here, and 4 here at the same place at the 2 2 location again, and it's 7 here. Now if you see carefully, the first row in the original matrix becomes the first column in the A transpose, and the second row in the original matrix and second row in the A matrix becomes the second column in A transpose, and it's our second point here. And it's very easy to apply second point to find transpose of matrix. Okay, let's go to second point now this time and take another example. I have matrix A here, and I want to find its transpose. It's 2 6 1 minus 2 3 5 and 2 1, and I want to take transpose of this matrix. Now according to second point, the second row becomes, the first row becomes first column in transpose of matrix, so I can write column like that. Second row becomes second column, third row becomes third column, and fourth row becomes fourth column. So this would be the transpose of matrix A. In other words, we can write like that: the first column becomes first row, and second column becomes second row of transpose of matrix in transpose of matrix. So I hope you learned what is the transpose of matrix and how can we find transpose of any given matrix, and what are the different properties of transpose of matrix. See you guys in the next video, and try covering some examples on your own, and see you guys in the next video.